SIwave is a power integrity and signal integrity tool. MTTF is one of the tools in SIwave and will be discussed in this video. MTTF stands for medium time to failure. MTTF is a necessary tool to understand the lifetime of the PCB based on the DC current density distribution calculated using the DCIR solver. It uses Black's equation to calculate the median time to failure of a semiconductor circuit. So MTTF in general, the way they define it as a maintenance metric that measures the average amount of time a non-repairable component or structure operates before it fails. In a previous video, we showed how to do a DCIR solution for a PCB. Once you have a solution, then you can do MTTF. Like any other solver in SIwave, the moment you click on the solver, SIwave displays a dialog box and expects the user to verify the contents, then it starts solving. So if I come here, this is simulation, and I select MTTF, I get this dialog box. We can see the equation, and we can also see the definition of all the parameters. So J is simply the current density, and the EA is what we call the activation energy. N is defined here. This is how it's defined. You can modify that. And K is the Boltzmann constant, and T is the temperature of the PCB, and that's the temperature you see here. Now, if you have IcePack, you can solve the temperature distribution, and from there you can put it back into this formula. The warning number and the error numbers are just thresholds that we establish at the beginning to be used in the post-processing. It will help you a lot to zoom in on what we call bad sections very fast. So if we are happy with what we see here in this dialog box, we can save the setting. And if it's simple like this, we don't need to save it. If we accept the default, then we go and we launch. And if you launch, of course, you get a solution. So let's take a look at the solution. What does it look like? Once we have a solution, now we can plot the results. So the first thing we can see is plotting the MTTF distribution inside the PCB. So we can plot all of them simultaneously. You can plot all the layers, or we can plot the top one alone, or the bottom one. You can hide the structure. Now you can see clearly the MTTF numbers, and here you can see the scale where you can see the numbers. You can double click on the scale and you can modify the scale, the structure, the setup of the scale, the min and the max, and whether you want it to be linear, log, or log scale in dB. Usually the log scaling is the best way to see it, to see this kind of parameters. Now, if you move your mouse around, you can see the numbers also. That will give you a better idea of the time to failure if you put a component at any one of these locations. Now, you can display the components by activating this column. You can see the location of the components. So for example, if we're looking at the top side, I can activate the top one only. Then I can zoom in on the location of these components, and from there I will be able to tell what's the lifetime of these components. Now, sometimes it's very difficult to zoom in on bad sections. So the best way to do it is to use the second feature here, which is displaying the warning and the errors. If you remember, when we did the setup, there were two numbers related to warning and to errors. and it's here where we use them. So you can see if everything is green, then it is below the warning number. If it exceeds the warning number, then we get yellow regions. And if it exceeds the error one, then it's red. Now, if you see any red spot, then you can zoom in on it because it's really, really bad. The current density there, it's extremely, extremely high, and you need to find a way to reduce it. Now, in addition to displaying the MTTF, you can also plot it in a table. So if we go to table here, we'll get a table where you can see the numbers based on a specific selection. Like, for example, if you say, I want you to tell me about all the regions in my PCB that has less than specific number of hours of operation, then you can do that. The location and the number of hours. It will tell you which layer, the location, and the MTTF hours. Now, the good thing about this table, you can also zoom in on vias. Of course, you can display vias in the plot, but the best thing is to look at them in a table. Here you can zoom in on the vias also and see the lifetime of every via in the PCB. It's very important to focus on the vias because they are the weakest element in a PCB structure. So this will give you an idea what is the lifetime. Of course, it will start with the shortest one. This is in hours, then 15, then 16, and 17. So you'll be focusing mainly on the first part to make sure that these numbers are acceptable to you. So as you can see, from doing the MTTF, I can examine the lifetime of my PCB, whether the metals themselves, the components, and also the vias. Thank you.